So this week on DIY Smart Home, we're going to introduce you into a little NodeMCU project with ESPHome to solve that issue of the fog rolling out of the shower from the kids or significant other maybe, or maybe yourself when you forget to turn on the vent in the bathroom. Let's get to it. So in one of my previous videos, we showed a little DIY multi-sensor with a motion sensor, temperature, humidity, lux, and a status LED in a little 3D printed case. But can't really plug that into a bathroom with ease and not have someone mess it up or bump it or move it out of the way, get wet, etc. So, well, we put one up in the ceiling. That way it's out of the way, no one messes with it, and it just does its thing of doing humidity and doing motion as well. And it doesn't run off of batteries. We do run 5 volts DC power to it from the attic, but it handles all of our automations and turns on our vents and also turns on our automated lights using the motion sensor. So with all of our builds, you don't have to follow exactly what we do, but maybe just some ideas to spawn something in your home and do something a little different. So be sure and share your ideas and maybe things you've used down in the comments down below. And of course, hit that subscribe button if you haven't already and that thumbs up. We do appreciate it. So let's jump into the project and get to it. And speaking of sensors and custom little builds in your DIY smart home, well, of course you're going to throw together a board and put all your little sensors and whatever it might be, and you're going to get built by PCBWay. And if you're not, well, go check them out. They got some cool projects, they got some cool products and great prices and deals always going on. Go check out their website. Maybe you can get your next project built at PCBWay. So right out of the box, the NodeMCU comes soldered with these headers already for you. So there is no need to solder any of the pins on here. And it does also come with a USB jack for programming or power or whatever it might be. Makes it real simple. It's a little development board. Then on top of that, you'll need some DuPont jumper wires, and these are just look like kind of like your old IDE ribbon cables. If you've been around hard drives that long, well, we may be dating ourselves at this point, but whatever. And you simply just pull off whatever wires you need from the bundle, and then you can just simply put them on to the pins that you want to connect to. And the pins are labeled, which we will get to a closer zoomed up view in a little bit. And they also do make other links of the DuPont jumpers as well. You got these 2 links, and of course we will leave the links down in the description of the video as well. They do make some male to male and female to female. These are going to be the female to female style ones that we use to hook up all of our various sensors, such as a temperature sensor, and you just simply connect the DuPont jumpers. Pretty simple to do. Anybody can do it and get a sensor running with either Tasmodo or ESPHome. And we're going to be using ESPHome in this build. And then they have the Wemos D1 Mini. They have different clone models of these, and you can see this one has the little ESP module in the case. But of course they don't come soldered up. They do come with the USB on the back, and they also have a couple other different models. This is the Pro model with more flash memory. It does have an external Wi-Fi antenna, so if you wanted more range with it than just a simple little onboard antenna that's on the PCB. But one thing I do prefer over the Wemos boards or it has more connections for 3.3 volts and ground. Now, one other board which we're not going to be using in this project, but I did want to show you, is the ESP32. It's the big brother to the ESP8266. It has additional GPIO pins for more sensors, plus it has the hardware LED drivers, it has Bluetooth, it has a multitude of additional features, but it is only supported at this time by ESPHome, and there are some little changes you need to do for supporting this board, but we're just going to keep it simple. As these are a little higher cost, we're going to be just using the NodeMCU. So looking a little closer at the board, you can actually see now the labels. They do show them as D0, D1, D2. I really hate this terminology of these labels. I'm not sure why we just didn't stick to GPIO pins. There's many times I'm actually having to look up a conversion table, and there's many on the web where you have to actually look up what is D3. D3 may equal GPIO 4 or whatever it might be. See, I don't even remember right now what they are. But you got D0, 1, 2, 3, 4, 5, 6, 7, and 8. As well as you do have RX and TX. That's a little different when you have to use those. We're not going to be using those, but you'll see there is duplicate pins, which makes it nice for doing a little sensor build. You can hook up multiple sensors and you don't have to split your DuPont jumper wires, and then you're having to make little jumper boards, or you're having to do some little bootleg splicing, etc. So you'll see there's ground and 3.3 volts here, as well as you've got 3.3 volts and ground here. And flipping the board over, you've got 3.3 volts and ground here again, as well as you've got your voltage in and ground. Voltage in is going to be for 5 volts. Now some of the NodeMCUs you can provide them with up to 12 volts or more. You do want to make sure the voltage regulator supports that. I have used these in some WLED projects with 12 volts and let them run for a month or so, and they ran fine. But of course, do look up the specs on your voltage regulator. We're going to be using just 5 volts to power this, and it will step it down and do the 3.3 volts for us. And you can choose to power it over the voltage in pins, or you can choose to power it over the regular USB port as well. And most of these NodeMCUs will have 2 LEDs. You can see there's an LED right here, as well as the ESP module has an LED on it as well. So if you wanted to build in some sort of status lights, you can use these 2 LEDs. So just like we did it in our multi-sensor build video a good while back, we are going to be using the AM312. It's a cool little PIR sensor for doing motion, and simple to hook up, just 3 little DuPont jumper wires, and the way she goes, just a digital in and out. And we are going to be using the BME280. It does give us humidity, temperature, and pressure, which we probably don't really need the pressure, but I have found even in a high humidity area such as a shower, it still works great and doesn't get oversaturated like some sensors. And last but not least, we are going to just go ahead and throw in a status light, which this is just basically a 1 pixel that is addressable. So it does RGB, and all you have to power it with is just do power, ground, and data, and you can create whatever colors you like with it at whatever brightnesses that you like. Pretty simple. Instead of having to do a LED that has 3 separate channels and then use 3 separate GPIO pins, this is only going to use 1 GPIO pin to drive it. Makes things a little easier for hookup. This other pin we're not using, that would go on that's the data out. That would go to another LED if you'd want to connect multiple LEDs, but we're not going to be doing that in this build. So for connectivity on the BME280, you do have, this is an I2C, so you do have 3.3 volts in, ground, and you got clock and data. So it's going to use 2 GPIO pins. So for the voltage in, we're going to use red, and ground, we're going to use the green. Keep the color code simple. and orange is clock, and yellow is data. And then we'll use D1 and D2. Then for the little NeoPixel, it's going to be data in, voltage, and then ground. So we'll use these pins on this side, the 3.3 volts and ground. And we'll use D5 for the data line of the NeoPixel. And then on the AM312, the starts with the voltage in, signal out, then ground. So we'll use the 3.3 volts on the other side. I do also believe you can power this sensor with 5 volts due to the voltage regulator it has, but we'll be using the 5-volt pin actually to power it. So we got the voltage hooked up. Now we need to hook up the actual digital signal. And we're going to use D6 for that. So that's all you need to wire it up. And next we need to flash it with ESPHome. Now, of course, again, you could use Tasmodo for this, but we're going to use this and build it with ESPHome because we can do some of the fine tuning of these sensor pulls. So to solder up these little I2C sensors, they're pretty simple to do. We are using the Heiko, or is it Paco? I don't know. I always tend to hack names up, but it's a pretty neat little soldering iron because you can control the temperature and it does heat up pretty quickly. I do highly recommend a soldering iron that you can control the heat because you don't want to overheat things and end up burning your board. And of course, we do have ones we've used before on our Amazon list or on the description of the video down below. So one easy way I like to solder these is using a breadboard. And the breadboard, if you're not familiar with, is for making up some little simple circuits where you can put on, say, a Wemos D1 Mini, NodeMCU, etc., and try out different sensors without soldering anything up. So we'll go ahead and fire up the soldering iron and get it heated up. And we'll go ahead and clean our tip once it gets heated up, and we'll zoom into the breadboard. So what you'll want to do is just pick you a spot that makes it easy to work on and take the pin header that they give you with it, and it should be the same size as the 4, and just put it in a spot on the breadboard and push it down. Pretty simple, and it keeps it held for you. Then take the sensor and simply slide it onto the pin header. And that's it. It's going to be and keep itself positioned. You can see it's pretty light, so it does stay at the proper angle. Then we'll take a little soldering paste. I'm just using a Q-tip to put it on with. Of course, you can use whatever you like to brush it on. And sometimes I do find it's easier to slide this up a little bit and then just apply a little bit on those pins. And that will allow that solder to flow into those joints with ease. And I'm not any pro at any soldering, so I'm sure there's going to be many people down below sending comments of, hey, I did it wrong or should do this. But as always, we welcome all comments, so feel free to comment down below. And one thing you should do is you want to create a good soldering joint, you want to heat up the actual joint and the pin, and you should see the flux melt a little bit, and then apply solder on the other side. And I am using a very thin solder, so it does take a little bit to do, but I find soldering with a thin solder is easy, and it will flow right in and make a good contact. And always start with lower heat and kind of come into it till you can figure out your soldering iron. And that's all there is to it. You got your sensor soldered up. We'll just clean off the extra flux. You can use some, like a toothbrush or something with some denatured alcohol on it and just rub it across and then let it dry and you should be good to go. You can see you got some nice shiny contacts and soldered up. Pretty simple to do. And you have no bridges in between. And you can see the purple all in between each joint, and that way you know you're not connecting, say, voltage and ground or the clock and the data together. So I know we talk about Tasmodo a lot and putting all our switches and plugs and light bulbs and everything. Well, there's another little cool project that also is flashable to your ESP8266 devices, as well as the ESP32, which Tasmodo doesn't support at this time. Well, I like to use ESPHome on all of my multi-sensor builds because it does let you dive a little deeper into the settings of each sensor. Now, of course, there is pros and cons for each project. Some people like to use them on their switches and plugs, and well, we possibly will get to do that in this DIY smart home and show both sides of the coin there. But we're going to dive into this little project here and show you all the different pieces that we did with the BME 280 and the motion sensor and LED, etc. If you haven't already seen my DIY multi-sensor video, it's a good little deep dive into all the different settings on different sensors using the documentation here. So definitely check it out. The link will be up here or maybe down below. It's a good little watch. So in Home Assistant, you will need to install the add-on for ESPHome. To do that, we'll go into the supervisor. So if you went into the add-on store and you've done a search for ESPHome, you can see you're not going to find it. Well, head on over to the documentation of ESPHome. This nice little button says Getting Started with SIO or Home Assistant. And scroll down and you should see the installation with the URL. Just simply copy it to your clipboard. Come into this field, says Add New Repository by URL. Paste it in and hit the Add button. And now you should be able to find ESPHome. And there it is. And you do have the option of installing the beta or the dev version. There are some additional features that possibly you might get out of dev if you're looking for some different sensors that have just been added. And you can check those on the GitHub page. Go into ESPHome, click Install. And we'll go ahead and hit the Start button. And we'll go ahead and do Show in Sidebar and open Web UI and see if it's working. So there it is. And it's going to get the message to say set up your first node. So we'll go ahead and do that. We'll come down to the name of the node. We're going to do DIY Sense. And take note, it does need to be lowercase and does not contain any spaces. We'll continue. We'll go ahead and pick NodeMCU for the type of chip. Hit continue. And the Wi-Fi SSID, we're going to get to, I'm going to show you how to do that one. So you can just put in anything you want right here, or misspell it like I did. And we'll hit continue. And then we'll hit submit. And it's going to give you this select upload port. Let's not mess with that right now. We'll click off of that. We're just going to leave it at OTA, and we'll explain that in a little bit. And there we have our first sensor. It's DIY Sense. And if you do get a message that says unknown status and this path isn't filled out, I did find I had to refresh the page, and that did fix that issue. So once you do have your first sensor added, there is one little feature we would like to show, and it is the secrets editor. Now, the secrets editor is not really just for your secrets, which are your passwords and other user IDs that you don't want to share on live streams and other places. I also use it for static information, since I use a couple different VLANs in my home where the sensors are on one VLAN versus my main network. And there has been an issue where sometimes I can't see the sensor being online or not. So I like to use the static IPs in my ESPHome sensors. And instead of keeping these static IPs in each YAML file separately, I like to keep them in the secrets. That way I can see exactly which IPs I've used. Now my screen may look a little different than yours because we do have it scrunched and zoomed for the recording of this video. So I'm going to paste in our first IP address, and simply you're just going to put in, this is the title of the secret and then the content of the secret, which we'll get to use in the YAML. You'll see it's real simple. And I like to use my gateway, subnet, and DNS. That way I don't have to put those in each YAML file. And if I ever need to change them, I can just change them right here in the secrets file. It changes it for all the YAML files and all my sensors. So for the Wi-Fi SSID, and we'll put our password. And once you have the information in, just hit save. And then we'll be able to use those in our YAML file. And now we're ready to edit the device YAML. So you click on edit. And we're not going to dive into every single option. If you want to see some additional stuff, we did do our DIY MultiSensor where we really dove into each sensor and how we pulled that out of the documentation. We're going to share the YAML file, of course, of this sensor build in the description of the video down below. And you're welcome to copy and use that. And if you would like to, also after you watch the video, go dig through some of the documentation and see how we did things. It's really helpful in seeing exactly what you can do with this thing. So a couple things I like to do. I want to use my substitution. And what that allows me to do is in each sensor, I can put that name before it without having to retype that name over and over. So we're going to leave the ESPHome section the same, copy in my Wi-Fi section, and this is where the secrets come in. You can actually see I am using, it's just the exclamation point secret, and then you put the tag you want and it will pull that from that secret file. So we're leaving the logger on. We're going to use the API here. You're welcome to use MQTT if you like. It does work with that as well. And we're going to do OTA, which means we can do it over the air update. So when you do make any changes to the configuration, you won't have to physically connect it back up. You can just hit the upload button. It sends it straight over the air to it. We'll also put in the web server with the default port. That will allow us to browse to the actual sensor, and we can just foresee the log and the sensors if we like. For the binary sensor, we are using that motion sensor on D6 pin, and here's where that substitution comes in. It's going to put actually DIY sense motion on the actual GUI in Home Assistant. Then for the little status LED, it's just a single pixel, so it gets one LED, and it is on D5, and it is using RGB color order. If you had a little different LED that was, say, green, red, blue, you would just change the letters around there. And then we need I2C, which is using D2 and D1 for data and clock. And the scan means it will scan that bus and look for other sensors. And possibly in case you do have a little different BME 280 or a different sensor, it will show that address. That will help you get that address if needed. So in the sensor, here's that BME 280. And we didn't need a lot of the default oversampling. We just used 2x on temperature, pressure, and humidity, and our sensor address was 76. And if yours is not, you can just use that in the log. It shows you in the scan. Some BME 280s are on 77. And here's where the cool part is. I like to use the update interval of only 30 seconds because some of the BME 280s, they will have an issue with self-heating if you continually poll it too often. And you can find that if you Google around the web, you can find that as kind of a common issue. So we only pull it like 30 seconds. So really that's all we need. And that prevents that self-heating issue, as well as we use that to prevent that rocking issue where it keeps rocking back and forth and turning the vent on and off in our automation, which we'll get to later. And then last but not least, throw in the status LED. It just helps you show the status on the actual NodeMCU. It's on pin D0. There it will show the status light for, say, it's connecting to Wi-Fi, etc. with ESPHome. So once you're done, you hit save, hit close, and then we'll go ahead and validate and see if we had any issues with tabbing or misspelling things, etc. And we got the thumbs up, good to go. Now, if you did have the NodeMCU directly connected, say, to their Raspberry Pi, you could just choose the upload button right here, and it would compile and send straight over as long as you did pick the port up above in the GUI of ESPHome. Now, we don't have it connected directly in this case, so what we're going to do, we're just going to go ahead and hit close, and then we'll hit the three little dots, and then we will hit compile. Now, if you have yours directly connected to the Raspberry Pi, you can probably skip some of this, but hey, you may learn something as well, and you can see how to actually just flash the bin file using your computer. So we'll go ahead and hit download binary. And once that downloads to the computer, now one thing you're going to need is the ESPHome bin flasher. It's a little simple little utility. It will flash it straight over USB from your computer, and it's real simple to use. So we'll jump on over and get the ESPHome flasher. Go to releases, and we'll download the 64-bit version. We'll go ahead and open it up, and we'll go ahead and pick our COM port, COM5. Yours is going to be different probably. And we just have a simple USB cable connecting the NodeMCU on the desktop. And then we'll browse to the bin file we just downloaded. And then we'll hit Flash ESP. It'll go through and it will erase the chip and flash the bin file. Shouldn't take but a couple minutes, and it'll reboot, and we'll see if it gets connected straight into ESPHome. And that's it. You can actually see in the log in the ESPHome flasher that it is connected up, and it's getting the temperature states, the pressure, etc. So now it's working. We'll go ahead and close the ESPHome flasher and pull up the GUI again. And now we can see it's online and showing connected. If you want to, you can hit show logs. And this will show that it's the same type of logs you just saw in ESPHome flasher. And you can see it's connected. Hit stop. And it's not actually stopping the device, it just stops and closes the window. So we'll jump back into the regular Home Assistant GUI. Now right away you may notice there is a notification down below. It's saying new devices are discovered. So we'll go ahead and hit check it out. And it's showing our sensor, which is our DIY Sense. We can hit configure, and then we'll hit submit. We'll go ahead and put it on the front bathroom, and then we'll hit finish. So now once it's configured, we'll click on it and go to DIY Sense. And now you can see it is showing the humidity, the motion, the pressure, temperature, etc. We'll go ahead and hit add to Lovelace. That way it automatically makes a card for us. You can always change that as well. We'll say, yeah, go ahead and add it. At this point, if you did want to make an automation, now we're going to go over some automations in a future segment, but if you'd like to jump ahead, by all means, go ahead. We're going to be using Node-RED as well. This would be actually just using the automations in Home Assistant itself. And you can create an easy automation by hitting create automation with the device, and it kind of walks you through a little wizard of, say, turn the LED on, turn it off, when there's motion, etc., and you can jump through there. So we'll jump back to the main screen, and you can see the LED lights up. And of course, if you want to change the color, you can change it to blue, the green, etc., as well as you can change the brightness if you wanted a dim brightness. So we'll possibly might use it for a fan override, just to give the user ability to look up and see if the fan is on override mode or not. And we'll check out the motion sensor, and we can see it says detected. Everything is working well with the sensor. All we have to do is put it in the box and get it installed. So that about wraps it up for this one. Hopefully you enjoy and get your sensor installed in your bathroom or whatever it might be. Now, of course, all the links to the products and every piece of software we install will be down in the description of the video. And if you use those links, we appreciate it. And of course, a big shout out and appreciation goes to these Patreon subscribers. It helps bring new projects and new videos to the channel each week. And of course, we're going to jump into doing some Node Red and some automations and automating a few different things in the home now that we have a sensor built. So be sure, hit that bell icon, hit that subscribe if you're not a subscriber, and catch our next live stream or video, and y'all take care.